Good afternoon, class. Welcome to Flip This Classroom with Dr. Platko. Today we are jumping into Chapter 5, 5.1a, where we start exploring identities. Actually, you have done half of these. We just need to add on to what we already learned in Chapter 4. So today, students will learn and memorize basic trigonometric identities. Everything on this sheet needs to be memorized. Also, students will simplify trigonometric expressions using basic identities. Anything on this page is what we consider to be basic. So, basic trig identities, starting with reciprocals and quotients. You guys already know these, but we need to jot them down. When we think of the sine of an angle, sine of theta, remember I can put anything in for theta. I could use an x, I could use a t, I could use alpha, anything can follow that. It's representing an angle. The sine of theta is equal to 1 over the cosecant of theta. If you want to work ahead of me, you can go ahead and list all the other reciprocal identities. The cosine of theta is equal to 1 over the secant of theta. Tangent of theta actually has two identities. It's 1 over the cotangent of theta. It's also sine of theta over cosine of theta. It's important that we also write down cosecant of theta would be 1 over sine. Secant of theta is 1 over cosine. And cotangent of theta is 1 over tangent of theta. Again, he has two. That would be cosine over sine. Okay, you should by now already have those memorized. Moving on to Pythagorean. We talked about Pythagorean identities earlier on in the first quarter. We're going to write them down again. Cosine squared plus sine squared is equal to 1. That comes from the Pythagorean theorem. So you guys need to recognize any time that you see cosine squared plus sine squared, it can be replaced with a 1 because that's its identity. Also, we can manipulate this equation. We can say that cosine squared theta equals 1 minus sine squared theta. You need to recognize at any given time that this could be replaced with a cosine squared. Finally, sine squared theta could equal 1 minus cosine squared theta. These two things are interchangeable and can be replaced at all times. We also have 1 plus tangent squared theta equals secant squared theta. Again, that needs to be memorized. We can manipulate these. 1 equals secant squared theta minus tangent squared theta. All I did was subtract tangent squared from both sides of the original. Right now I have secant squared alone, I have the 1 alone, and so I should write and isolate the tangent squared. Keep that alone. So tangent squared would equal, I need to subtract 1 from both sides, secant squared theta minus 1. The last set for Pythagorean identities is cosecant squared theta minus 1 is equal to cotangent squared theta. It's essential that we can isolate the cosecant squared at any time. That would be cotangent squared theta plus 1. And the only thing that has not been alone is the 1. So if I isolate the 1 in this equation, that's cosecant squared theta minus cotangent squared theta. Okay, we have already covered all these, so I am expecting that you could look back in your notes if you wanted to see why cosine squared plus sine squared equals 1. We're going to go back to the trigonometric toolbox at the end after I go ahead and copy down the cofunction and even odd identities. Cofunction identities. Again, these have also been explained to you before. You need to look back in chapter 4 for a refresher of why the sine of pi over 2 minus theta, is equal to the cosine of theta. In the same way, the cosine of pi over 2 minus theta is equal to the sine of theta. This works with tangent and cotangent. The tangent of pi over 2 minus theta is equal to the cotangent of theta, and the cotangent of pi over 2 minus theta is equal to the tangent of theta. Finally, this works with cosecant and secant. The secant of pi over 2 minus theta is equal to the cosecant of theta, and cosecant of theta, nope, cosecant of pi over 2 minus theta is equal to the secant of theta. So when you're looking at your cofunction identities, basically what this is this is a phase shift. You can either move to the right or left for most of these to work. You guys know that cosine and sine look nearly identical when you graph them, so it's just moving them to the right or the left pi over 2. Tangent and cotangent, same thing, but tangent and cotangent require a flip upside down. And finally, secant and cosecant, they can be shifted over to the left and the right to meet up with each other. So that is why the cofunction identities work. One of the reasons why. So in this case, we often talk about buddies. Sine and cosine are buddies, tangent and cotangent are buddies, and secant and cosecant are buddies. We really don't try and do a lot of tricks with these. We might get to something where this is backwards and it says theta minus pi over 2, which would be a little bit different, and we'll talk about that. If theta is first and it subtracts pi over 2, then you'll need to think about even odd, which is coming up in the next section. So you should know right now which two functions are even and which four are odd. So you're thinking, which one are you thinking is an even function? I hope you are thinking that cosine is an even function. So here's how that works. Whenever we take the cosine of the opposite of theta, it will report back the cosine of theta. And we've explained this multiple times. It's symmetric about the y-axis. So it doesn't matter if this theta is a positive value or a negative value, you still get the same output. In the same way, secant is symmetric about the y-axis. Secant of negative theta is equal to the secant of theta. You do have some odd functions. All of the other ones are odd. So the sine of negative theta is equal to the negative sine of theta. Sine's buddy, cosecant, is also odd, so that means that out here in front, you'd put a negative sign. Tangent is odd. So whenever you evaluate that, you'd get the opposite of the y value that you were expecting. And cotangent of negative theta is equal to negative cotangent of theta. Okay, so what you're looking at is when you see cosine of negative theta, you'll replace it with a cosine of theta. There is no sign in front of here. When it's odd, sine, cosecant, tangent, and cotangent, and they show a negative value for an angle, you'll know that the output is also negative. So recall that your odd functions are symmetric about the origin by 180 degrees, and even functions are symmetric about the y-axis. And we have discussed this quite a bit in previous lessons. Okay, we are almost finished with this part of the video. Of the video lecture, we need to talk about our trigonometric toolbox. You guys will refer to this quite a few times in this entire chapter, so you do not want to lose this piece of paper. Number one, a trigonometric toolbox is the tools that you will use to work with identities. One of the first things that you want to have on your mind is factoring. Okay? In the same way, sometimes expressions will be shown in a factored form, and in that case, you will need to expand. So they kind of are opposites of each other, and you need to be ready to do both. Always, always, always look for identities. Always. Identities make the whole process simpler and more efficient. So as you guys get older, you are looking for ways to problem solve efficiently. Looking for identities is how you do this in this chapter of mathematics. We're going to multiply quite often, and you need to understand that multiplication is a really important tool in mathematics because there's some neat things that you can do with it. You can at any time multiply an expression by 1. Now, 1 over 1 won't change the look of it, but you can have a well-chosen 1. Meaning, we could multiply by sign over sign, and that might really help us change the look of our identity to help us finish the problem. So we'll talk about that a lot more later. Also, if you recall from working with imaginary numbers, we often multiplied by conjugates, and so it's important to realize that you can do that in this case too. Thinking about what a conjugate is that if you have an expression of a plus b, multiplying by a conjugate would be multiplying by a minus b. You just change that symbol in from addition to subtraction. It's really helpful to split fractions, split one term into 2 fractions with a common denominator. And then finally, you need to know that you might change everything in your identity or in your expression to sines and cosines. Now, I want you to be leery of this. Every year there are people that think this is the best way to do things, okay? Let's undo that little writing there. This is not the most efficient way to handle these problems. So this right here is what we're going to call a last resort. Okay, I am going to sign off for this video. I hope you enjoyed your first and second lessons, and we'll get to some examples here shortly. Thank you. Have a good night.